let's welcome Max from Lido, Zahary from Metacraft Labs, Misha from Nil Foundation, John from Succinct Labs, and Alex from Lido.
Thank you, Ivan. Yeah, I'm Max. I'm a contributor for Lido, part of analytical workstream, and I'm really amazed to have these fantastic people here with me on panel. I'm kind of like the curious guy on this side, on ZK, so would be representing auditory as good as I can in terms of understanding the technology here. And my first question would be actually for Alex, who's also a contributor for Lido, to provide a little context on like what is ZK Oracle technology, how it's like emerged, how it was proposed to DAO, and what are the next steps?
Hello, everyone. I'm Alex, and I'm core contributor of Lido that occasionally responsible for the ZK Oracle integration into our protocol. And will not be talking about ZK because I am not really an expert here. There is a guys that know a lot more. I will talk about the problem domain. Actually, we have this long-standing risk in our protocol that was highlighted by various auditors, and the risk that the Oracle, which our protocol are based in, will bring us wrong data. And I explain it in more details. Currently, the protocol trusts a committee of 9 oracles, which are run by reputable third parties, and which are responsible of bringing this data from the beacon chain that defines the protocol TVL. So it's a founding stone of our accounting. And right now, we just trust in them that they do it honestly. But with EIP 4788, we can implement the trustless solution utilizing this ZK technology and go to the trustless utopia. But it looks like it solves almost our problems. We can build a bot that just delivers proof and the values to the protocol. We can trustlessly do it, and anyone can do it. But there's still real world around, and we have real world issues like reliability at first. So this imaginable bot just can fail to deliver, goes down, and even Facebook goes down sometimes. And also we have some risks of bugs and vulnerabilities introduced into our solution because it's very complex and not really intuitive thing. So we are proposing a solution for these problems. It's called multi-prover, actually 2 out of 3. So the 3 different implementations of ZK Oracle will bring data on chain, and if data is equal and proofs are valid, we will push it to the protocol, basically. And it will improve reliability, it will improve security, and so here we are with the guys that we are collaborating with to provide this solution.
Thank you, Alex. That's fascinating. So, like if I'm getting it right, like no amount of security is enough, especially in terms of oracles who are responsible for like the major functionality of protocol. And like these amazing people are representing the teams that responded to like the call for improving security with like extremely like interesting and orthogonal tech of delivering the data to the protocol. If we want to, and I would love to, could you explain a little bit more how each of your teams are solving this problem? Maybe we could start with you, Zahary.
All right. I guess the best idea is obviously the same for all teams. We will leverage EAP 4788. This is the introduction of the beacon state root in the execution layer protocol. And now theoretically, you have all the information to implement something similar to what we are doing in pure Solidity with Merkle proofs. But the problem would be that this would consume way too much gas. So our teams are leveraging zero-knowledge technologies, not to introduce secrecy or anything like that into the solution, but rather to compress the computation, to make it more efficient for verifying on-chain. But basically, the proof doesn't do something too complicated. Lido is a protocol where all the validators use the same withdrawal credentials. So basically, we have a zero-knowledge circuit that scans the entire set of validators. It locates the ones which are using the specific withdrawal credentials of Lido, and it accumulates, aggregates their balances on the chain. While doing this, you have to kind of make sure that private inputs are given to the input, which are kind of Merkle proofs, which are verified against the known state root, and that's how you know that the computation is completely authentic.
That's fascinating. Thank you. So, like, you're also working on like lowering the burden cost of transaction, of like making it even more efficiency on the Oracle. That would be like the main, you know, thing with your technology.
Yeah, this is one area where kind of the solutions of the different teams differ to some extent. This is coming from the fact that we are all using different zero-knowledge technologies to generate a solution which is contributing to the security, because one of the key idea why there should be multiple provers is that if any of the implementations somebody discovers a vulnerability of any sort or implementation bug, then likely the other implementations wouldn't be affected because they are constructed in a different way.
Okay, so if you can trust no one but 2 of 3, let's ask 2 another guys. Misha, could you provide some info about you?
All right, 2 out of 3 then. So basically, yeah, that's the idea behind this whole project of ZK Oracle was, you know, initially it was born maybe like about a year ago or something. The first implementation of such an Oracle, collecting all the validator balances, summing them up, and then providing this information to the protocol to ensure that no TVL is, you know, reported wrong, which, you know, it reduces risks. It's like some risks, let's this way. And the first implementation was done about like a year ago by, you know, by the team, by the same team. We've built together the current version of the Oracle of ours. So what do we push for is that the security of such an Oracle actually, I mean, if something's wrong with it, it can, you know, harm the entire industry. So we try to avoid this. And, you know, as Zahary said, yes, we all use different tech. On our side, the tech we use is we try to do, instead of, you know, writing circuits manually, we try to write them with a high-level circuit compiler. So that makes them auditable, and like literally anyone in the industry can, you know, just take a look into that, you know, audit and see that, okay, TVL is reported correctly. It's good. It's cool. So that's like the primary purpose of this thing. So yeah, just let's, I don't know, maybe the third opinion, so you could trust 2 out of 3, huh?
Thank you. Yes, let's go. John.
Yeah, so I think the multi-prover approach is actually something that I think we see in a lot of other disciplines in crypto, specifically with like bridging, for example. I think, you know, in bridging, you also have this problem where you have these really important oracles that secure users' funds. And I think we're seeing that in, for example, bridging with like Gnosis Chain, they're also doing something similar where they have sort of like a N out of M sort of committee of different oracle providers, and they're aggregating that to secure their bridge. And I think also with Uniswap's governance, they are doing something where they're proposing the idea of using multiple bridges to do cross-chain governance for Uniswap. And I think, you know, it makes a lot of sense that all these teams are kind of converging to the same philosophy of combining multiple oracles and aggregating their security, because, you know, there's so much money on the line here. I think in terms of our approach and how it is perhaps a little bit different from the other teams is we've been just building a lot of open source software for the past year for doing, you know, large scale analytics over on-chain data. And I think, you know, just happened to be a good fit for a lot of the tools we've been building. And I think a lot of the tools we've been building makes it really easy for, you know, people on the Lido team themselves to implement the circuits. So I think that's more of the perspective that we're coming from.
Thank you. Thank you, all of you guys. It's really impressive, like in terms of general view of like adding new scale of the Oracle, I would say like problem, because we can like expand the set of trustful Oracle to like 90, 900, but all of you solving the same like final issue of delivering information to protocol in orthogonal ways, like brings another level of security in terms of risks. That's really impressive.
Yeah, can I add one thing? I think one interesting thing that maybe the crowd here may not understand is I don't think ZK is just like a matter of, you know, security of improving, you know, the Lido Oracle. It also, I think, in the end game will make, you know, Lido, people at Lido and their contributors, you know, their lives easier. Like right now, you guys are running this complicated Lido accounting Oracle committee, and you have to like find operators for it. You have to, you know, make sure the code is correct, which I guess is still true with ZK. But the magic with ZK is that now you don't have to go out of your way to get a bunch of people to run this Oracle for you. You can just trust the power of math. So I think it's not just a matter of security. Like, I think it also makes, you know, Lido's operational needs easier in the limit. I think right now the ZK tech is still a little bit early, so this is not entirely true. But I think this is more and more, yeah, I would expect that ZK becomes more and more of an important technology that Lido will use.
Thank you, John. Also, like echoing your story about magic of ZK, I have like some personal thing here. I think 3 days ago, I was calling my daughter. She's 3 years old, and she asked me to read her book. I didn't have a book in the hotel room, so I pretended to read a book, reading the freaking menu, and come up with a story about the raccoon who find the magic ZK coin. I don't know why. And then it got messed up. So guys, please help me. Could you provide, and I like genuinely know that this is the most stupid question about ZK, like could you provide the simple explanation of ZK? Maybe any of you?
Like, come on, for real? Okay.
I mean, if you don't want to, don't do this. It's.
I think the simplest explanation for everyone in the audience with respect to Lido is just verifiable compute. You can just do as much compute as you want for around 200K gas, which is, I think, right now around like $10 in Ethereum. And I think, I don't have exact benchmarks off the top of the head, but I think to run the Lido Oracle in Solidity would probably cost on the orders of like thousands of dollars, if not probably orders of magnitude more. So that's what ZK is getting you.
I would say it's not always comes at that cost, because that cost comes with additional security assumptions that you gotta trust, you know, a committee of those who did the trusted setup, which I wouldn't say you can trust if you try to stake that amount of TVL. So you shouldn't trust that, I would say. And that was like an explicit requirement for this to be absent. So yeah, I guess the cost of the compute depends on what is best for a particular solution. So you want more security, yes, it's like the verification cost of such a compute would be more expensive. It's like you can, I don't know, still rely on basically 5 out of 9 oracles, yes, you can, pay less. But in general, yeah, that's, I mean, it's verifiable compute. Some people use it for its blinding purposes, aka privacy use case. Some people use it for the sake of compression, computation compression, which is basically the second use case. It's all about it. That's it.
Thank you for this. Really, do you want to add something or pass on this?
Well, I mean, these were pretty good answers. I will bring the perspective of a compiler developer. For me, the ZK technology is like a new type of instruction set, a new target architecture that we can target in compilers.
Thank you. So, continuing this discussion on the 3 different solutions that would enhance the security of Oracle reporting, is any particular fascinating problems any of your teams faced doing this, or it was just a streamline, something that you want to share, then you want to discuss?
Well, if you want to talk about some particular problems, then the size of a validator set you gotta prove is the problem. It's like, I don't know how many, several hundred K. I don't know, don't let me lie, Zahary. It's like, I don't know, 800K validators currently within the Merkle
That's right.
And that's quite a lot of computation, let's say it this way. So trying to fold it somehow together, trying to make it work at all in general is effort consuming. And the more validators there is, I mean, until the proper EEP gets accepted to increase the threshold for the amount of ETH staked, well, it's going to increase. And yeah, that's going to be quite an effort to keep this contained within the proper limitations in terms of costs.
I think there are also other kind of interesting problems. For example, the fact that the Ethereum specification is not using zero-knowledge friendly hash functions. But we have kind of constructed a way to solve this problem by mapping all the kind of hash roots produced from stored in the beacon state to a much more efficient kind of hash system known as Poseidon hash. And this is what is a kind of incremental computation that you can do on the chip, but then it really speeds up the generation of each individual proof.
Yeah, just to add to that, I think actually in the context of ZK, I think the oracle that Lido wants is actually one of the most interesting applications that have ZK that would go into production if it were to go to production next year. And I think that's largely because of what Misha and Zahary said, which is the very large amount of data that we're dealing with is in many ways unprecedented, I think, in my opinion, in the Ethereum ecosystem. So that's really interesting. In our solution, and I think in both of your guys' solutions, the way you deal with the fact that it's very large is you have to parallelize a lot of the computation. And I think one contrast with a lot of the ZK-L2s that we see, ZK-L2s are a very sequential computation, but in Lido, it's a very parallel thing. So that's one pretty interesting part that I think requires technical innovation.
If you want a little bit more on the parallelization, it's don't forget about the proof generation liveness. Because, I mean, you gotta be able to provide it once in a half an hour or something, at least. So if it doesn't get provided, things might get, south. Things might go south. So it's, liveness. We tried to solve this with a thing we called proof market. I mean, just decentralized for this, a protocol. But in general, liveness is important.
I think, yeah, the proof market's definitely a really interesting direction. I think ZK also in general is, in many ways, more friendly to liveness because, for example, right now with the Lido Oracle committee, right, the only people who can submit the Lido Oracle updates are the people in the committee. But with ZK, assuming you can make it so anyone can submit a proof, then technically, as long as there's one, honest, capable party, you can sort of have liveness in your end application. So that's another really nice reason why it's amazing to use ZK instead of these committee-based approaches.
Thank you, guys. Yeah, again, Lido size is a problem. That's true. But, I mean, handling this magnitude stuff in terms of number of validators, it's our 800. It's inspiring in terms of demonstrating the actual fascinating technology you're using. And moving a little bit on your points of end game of anyone could using the technology to send the information on LTV, for example. Alex, would you mind sharing some context on the vision how the this system of trustless and lots of different oracles would be handled in nearest future and in the end game? In just your opinion, the DAO would vote and provide its vision, but could you give the side from the entity interested in the mechanism getting the most precise data as possible and as secure?
Yes, actually, right now we are at first stage of this implementation, and delivered data will be used as a sanity check for the actual trusted Oracle community. Because the current implementation will not include all the required data, for example, data for withdrawal decisions or execution layer historical data that we are also based on. But it covers the most important part, that one that takes most risks on it. So it's worth implementing even in this way. Also, the current solution is not precise at 100% because it's based on withdrawal credentials, and anyone can launch a validator with wider deposit credentials. I don't know if it will want to give away some ETH to Lido, for example. But so we have several directions to improvement. We will improve precision, and also we will improve the completeness of this report. So once we reach these goals, we will do the approach trustless, which fulfills the requirement for the governance, for example, to work. And also, after that, we can utilize this tech and these approaches in other parts of the system. Actually, there is several other points that we can improve using ZK technologies.
Yeah, got it. So it's gradually increasing, not putting your trust on, I generally believe amazing technology, but that's, we're talking about Lido TVL, we want to be as secure as possible. And on the next steps, could you guys share what's the short-term plan, when we would see the Oracle actually submitting on, maybe you have some more forward-looking ideas of implementing of different mutual projects with the DAO, of further implementing the tech you are experts?
All right, development on our side definitely continues. We want to address many of these issues that Alex mentioned, and we are also looking into other problems that can complement this report, such as one very interesting aspect, for example, is can you detect poor validator performance? Say some validator that they have missed a block proposal or they have missed their sync committee duties. Arguably, this creates a lot of opportunity cost for the protocol. So in bonded protocols, you could use the bond of the operator to compensate the stakers for such events. Something that's important to note here is that even though we've built this solution for Lido, our vision is that it really should be used in every liquid staking protocol. And what we have developed is allowing us to do that. It's developed as probably good. It's easy to integrate in other liquid staking protocols. We have also a different integration mode, which is more suitable for liquid staking protocols with a smaller number of operators, or one such that doesn't use the same withdrawal credentials for the entire validator set. Then you can use kind of Merkle accumulator for all the validators that you create, and the proof can be constructed against this Merkle accumulator. That's what we support. So development continues. We actually plan to go live on the testnet pretty soon with the first Lido adapter.
Yeah, that's fascinating, especially the thing you mentioned about like reporting, actually performance data on each validator. It opens up sharing the information on like different entities, solving lots of principal agents problems with opening up the protocol. Like Dmitry have a talk on community stake initiative, and yes, making the way to like share the information trustless and as precise as possible would definitely open up the new designs, not only for Lido, but for the ETH. Do you guys want to share your plans, your visions?
In terms of plans for this particular thing, I mean, the thing was deployed on Sepoila for, I don't know, a couple of months like already. So it's like, I don't know, yes, a couple of months already. So that's the thing. We're obviously like continuously improving that, and I don't know, just deploy to like the primary ETH of this oracle. I mean, you may or may not use it, but like it's about just reporting the data itself. Is gonna happen, I guess, till the end of the month, most probably. Most probably. Anyway, I mean, it's like primary ETH deployment. That's the thing. The rest of it, up to the audits and everything. Regarding the plans for, what this could be like of a use besides just, TVL usage, let's say this way, there are like quite some amount of use cases, quite some amount of those things in which security has to be threatened. I mean, yes, of course, like validators' performance is one of them. It's like another one is, I don't know, like for example, the risk, I don't know, depegging risk or something by measuring basically the liquidity available in the pools and automatic reporting of that, risk parameters of a validator being, of a particular validator being slashed or not, these kind of things as well. And the target for us is to enable protocol developers to develop necessary provable computations for the protocol themselves, because I mean, otherwise just going to some third-party team asking them to do this each time is simply, not really comfortable for the protocol team. So the end game idea is to enable protocol developers to just use, I don't know, some high-level language, okay, like Rust or like CPP or something, and to develop proper strategies for proper risk parameters to be proven via this by themselves instead of, just going and poking some third-party team each time. So, because considering even I just, made up some amount of these risks, and internally, I guess there are much more guesses about what makes sense to be, proven or not. So that's, like the end game for this particular like project on our side, I guess.
Yeah, that's like really fascinating in terms of like, trimming the unnecessary costs of sharing information and trimming the opportunities to actually like make it permissionless, make it risk managed by design or managed by the DAO, by the community, like trustful. That's, generally I can't use this word. That's freaking inspiring. That's cool. John, what's your take on that?
Yeah, I definitely want to echo Misha's point. Like, I think, yeah, right now, just frankly, the infrastructure and tooling around ZK is so bad that, it really requires for Lido to collaborate with other, teams that have ZK experience to make this work. But like, yeah, frankly, like I'm not the expert on liquid staking here, right? Like you guys are. So it just makes way more sense that you guys would be implementing, the core logic for the Oracle and not be required to talk to us to, deploy the, design or develop the circuit in a circuit, which I think is why Misha's excited about the high-level language approach. But I think, even beyond the programming layer, there's just also not good infrastructure to use this stuff. There's not good monitoring, there's not good explorers, there's not good cloud infrastructure to like parallelize the computation. And I think all these things are pain points that would go away in a few years. And I'm really excited for that world as well.
Thank you, John. So moving forward, and again, it's kind of tricky question, but I really genuinely want to know what brings you guys and your teams for like the technology of zero knowledge. Like, can you share the story of like how you discovered this like new world and started like, yeah, that's good. I should dive deep into this.
Well, I think I learned about ZK even before I joined the blockchain space. Literally, it intrigued me to exactly as kind of the fact that it's a general purpose verifiable computing. But this was kind of mostly curiosity back then. I was trying to understand, okay, what does it mean for a compiler engineer to target these systems? And I'm lucky that kind of my career allowed me to get to the point to work with this tech many years later.
Yeah, that's really inspiring. John, Misha?
For me, yeah, I think I came from a math CS background, and when I first came to crypto, I thought a lot of the super financial stuff like staking, DeFi, and stuff was super interesting. But I think I was looking for something that was very technical and math heavy, and I think the ZK technology really spoke to me. I think I quickly understood that it would be a very big part of crypto's future. So I think that's why I'm still excited to work on it today, as well for the fact that I think it's going to make a lot of progress in the next few years.
Thank you, John. That does explain why me with my economical background is mostly on staking. Misha, you want to share something? No problem. Alex, you want to tell us your personal story about ZK?
It just happened several months ago when I was thrown into this deep ocean of black voodoo cryptography to navigate it. And
it's like we made Losha dive into that, literally. He had no other choice.
Yeah, exactly.
Losha, wink if you need help. He's not winking. Thank you so much, guys, for coming here. I think we covered all the topics that I have on this tiny piece of paper that I've dropped. If you want to share anything at all or discuss something, we have time. We have audience here. So anything you want to bring up, or we should wrap it out and go to the party?
Yeah, thanks for organizing. This was a lot of fun. That's all I wanted to say.
You can say it after the party. That was a lot of fun.
I guess I should thank to the interesting panels before me because I was about to be late for this one.
Yeah, they were kind of good, but ours was the best. Thank you. Thank you for coming.